Very well. So when it comes to functions with more than one variable, we're interested in taking different types of derivatives. One of them is taking the derivative with respect to x, taking the derivative with respect to y. And if you have a function in three free variables, we're interested in taking the derivative with respect to z as well. Finding the rate of change of function with respect to each variable. So objectives, the derivatives. So the very first type of derivative that we're going to talk about is partial derivative. Recall that when you had a function like this, if you have y equals to f of x, then you took the derivative, you only had one type of derivative, y prime or y of x, which was the derivative of the function with respect to x. For example, if you had y equals to x squared plus 3, the derivative was 2x. Now, you're working with multivariable functions. It means that you don't just have one variable to work with. You have more variables. So instead of taking the derivative, you say that you're taking the partial derivative. You're taking the derivative partly. So let z equals to f of x and y be a function in two variables. The partial derivative of f with respect to x, it means that all other variables are considered to be constant. So the partial derivative of f with respect to x, it means that all other variables are constant. Okay. Let me give you one example. In this example, I have this function, f of x and y is equal to x squared y to the fifth. So I want to find the partial derivative of function f with respect to variable x. I'm going to denote it this way. Either I write it as f sub x, or I write it as d of f with respect to variable x. So you take the derivative and you assume y is a constant, like this case. F of x and y is equal to x squared times a constant. Let's call that constant a. So if I take the derivative of f with respect to x, it's going to be 2x. And here you have your constant, which is multiplied, which is copy down your a. So here you take the derivative with respect to x, which is 2x. And since y to the fifth is just a constant, constant, you're going to copy this guy down here. This is the partial derivative of f with respect to x. Let me write down the partial derivative of f with respect to y so you get the big picture. 2, the partial derivative of f with respect to y. It means that all other variables are constant. So if I have the same function and I want to take the partial derivative of the function with respect to y, I'm going to write it down as f sub y, or partial derivative of f with respect to y, which is, so again, note that when you're taking the derivative with respect to y, all other variables are constant. It's like this. You have f of x and y equals to b y to the fifth. So when you're taking the derivative with respect to y, you copy down the constant, whatever it is, and then you take the derivative with respect to y, which is 5, y to the fifth. So you're going to copy down your constant, which is x squared, and you're going to take the derivative with respect to y, which is 5, y to the fifth. Partial derivative with respect to x, partial derivative with respect to y. Now remember that if you forgot about this, then you have a power function. The derivative is n x to n minus 1. Well, give us another example. Okay. Well, let's take a look at this example together. Here we have f of x and y, which is x cubed plus x squared y cubed, and minus 2y squared. Minus 2y squared. Okay, perfect. We want to take the partial derivative with respect to x, with respect to y. So with respect to x, write f sub x, or partial derivative of f with respect to x. Okay, step by step, we're going to take the derivative. Here you have your first term, x cubed, so the derivative is 3x squared. You have a plus sign, you're going to write this guy down here. Then you're taking the derivative with respect to x. This guy is a constant. It means that you just copied this down. It is y cubed. Well, what is the derivative with respect to x? 2x. Okay, now here you have a term which is completely constant. The derivative of constant is 0. So minus 0, or simply you have 3x squared plus 2x y cubed. Okay. Let me copy down the same function here and take the derivative with respect to y. So taking the derivative with respect to y, partial derivative of f with respect to y. Okay, here we go. Guys, x cubed, x is constant. When you're taking the derivative with respect to y, x is constant. The derivative of constant is just 0. So you have 0 plus. Here you have multiplication. X squared is multiplied by y cubed. It means that even though it's a constant, here you have to copy this guy down here. It's just a times y cubed. So you're going to have x squared, and the derivative with respect to y, 3y squared minus. This term is completely in terms of y, so you get 4y short form, you get 3x squared y squared minus 4y